The pest arrest trap design process. The design process consists of 5 characters: S for spice, P for problem, I for investigation, C for construction, and E for evaluation. Situation. Within 3 weeks, the situation given to me was to make an innovation that would impact society in a beneficial way, all while applying the things learned in technological design as well as connecting climate change and one other unit in science. The product either needed to be something new or something that already exists but improved on. First and foremost, I needed to decide on a problem that I would be able to fix or improve. Getting started is the toughest part of the process, as I had a variety of ideas to go from. By the end, I decided to create what my product is today, the Pest Arrest Trap, and this is mainly due to the fact that I personally experienced a rodent problem within my house. I can understand how frustrating it can be when there is a countless amount of rats living in your house, and how difficult it is to get rid of them without killing. I realized this major problem needed a better solution than just a spring and trigger function, so I decided to tackle this situation. Problem. As I said before, as part of making the product, thinking about an idea was also very challenging. I had to propose many ideas to finally decide upon the idea I have today. We also had certain criteria we had to follow, such as I can accurately analyze and gather information about a problem that I'm trying to solve. I can use the design process efficiently and all the technical skills learned to create a working innovation. I can design a product that connects to at least one unit in science other than climate change and analyze the carbon footprint that would result from manufacturing their innovation. I can create a website that will be used as a platform to present and market my product and the process it took to get to my final design. Other things I had to consider: must be done by June 14, 2019. Use different materials for the design, so think recyclable or reusable materials. The innovation needs to work and be aesthetically pleasing. Should function as wanted and trap rodents inside whenever the sensor is triggered. There should be a lock system so when the rodent pushes on the inside, it doesn't get out. The wires, Arduino, and breadboard should be hidden from view to make the product visually appealing. Investigation. I had to research many things for my innovation. First of all, I had to decide what sensor to use for my innovation. There were many sensor options I considered. Some of these included the PIR sensor, a proximity sensor, a touch sensor, and an ultrasonic sensor. Ultimately, I went with the ultrasonic sensor, as I'll explain more about that later. I also found an Arduino kit on Amazon I could buy for myself to use that contained a servo motor and sensors I needed. I also needed to understand the code for my sensors and how they work. I found out that ultrasonic sensors consist of a trig pin and an echo pin. Ultrasonic sensors use sound waves and detect the distance. It does this by sending out a sound wave at a frequency and picks up the sound wave that bounces back. The transmitter sends the sound waves and the receiver takes the sound waves reflected back. In contrast, PIR sensors detect infrared light radiating from objects in its field of view. I also learned how to code an ultrasonic sensor, PIR sensor, and a servo motor. After researching, I began to make my sketches for my innovation. So now I'll explain all my sketches I made for my innovation project. So we'll start off with my first sketch. I'm gonna show you all the views I made and then explain how they work. So this is my isometric view. This is the diagonal view from the front. This is my top view. This is my front view. This is my bottom view. This is my left side view. And this is my right side view. So basically how this sketch works is by a spring and this little trigger over here. So the way this sketch would have worked is that I would have pushed this handle back all the way down and hook it inside this trigger. And then once the mouse comes inside, it would have the bait would have been attached on the bottom side of this trigger. And once the mouse would have touched it, then this hatch would have moved and gone up, well, resulting the hatch to close. The hatch was gonna have a spring attached to it, and then the other end of the string was gonna be attached to the wall. So that's how I would have captured the mouse. And then the code part of it was going to be back here. This is my servo motor, and this was going to be my release hatch. This was my capture hatch that didn't involve any code. It just involved a spring. This one was going to involve a servo motor. So this is a gear over here, and it would have been attached to the servo. I would have made the grooves inside this plate over here and made a 3D printed a gear, and then it would have rotated to open the hatch right over here. So this would have been a release hatch, and it would have been activated by pressing this button, and that was going to be before my release, and that was going to be for my capture. So things to note for this sketch is that it only uses one servo motor and a button and an Arduino. The hatch is being closed by a spring trigger, whereas an accurate sensor. It uses a rack and pinion mechanism for sliding for the sliding release hatch, and the it only traps like one mouse at a time before the reset. So yeah, and then as explained over here is that how this design would work. The handle of the spring hatch would be pulled down to go against the spring's compression, and the handle would be hooked onto the trigger. When the pest eats the bait on the hook part of the trigger would move, resulting the spring hatch to snap back, trapping the pest inside. The button would be pressed to release the pest from the sliding hatch. The button would activate the servo motor. So this is my first sketch. So the only problem with my first sketch is that the trigger and the spring is very close to the front, and I couldn't have them close to the back because my servo and Arduino is back here. So I don't think I would have enough space when I would pull this down for the mouse and rat to actually go inside. So that's a con in it. So now moving on to my next sketch. So this is my second sketch. I'm going to show all my views first. So this is my isometric view. This is my top view. This is my front view. This is my bottom view. This is my left side view. And this is my right side view. So over here, you could see that it involves two servo motors. So one at the front and then one at the back. So this was going to be a capture hatch, and this was going to be a release hatch. So and it would have involved a PIR sensor over here. So once the mouse goes inside, it would be in front of the PIR sensor, and then it would close this hatch, and then once you press this button, this hatch would open. So these two hatches will alternate. So when this hatch is open, this hatch will be closed, and when this hatch is open, this hatch will be closed. My Arduino and wires will be up here at the top, and my button will be over here. So things to note, that when the capture hatch is open, like I said before, the release hatch will be closed. The release hatch will only be open when the button is pressed. The wires will be covered by cardboard attached by Velcro, and I'm talking about the cover over here I made for my all my Arduino and my battery. So and then I'm just explaining what a PIR sensor is. A PIR sensor is a passive infrared sensor which detects infrared radiation from object in its field of view. So the only thing bad about this sketch is that it doesn't have a lock system. So when I would close it, I believe that the rotor inside will be able to just push its way out, as it's not very firm and stable. There wouldn't be any way I would be able to add a lock system because this hatch closes up and down. So this currently is open, and when it goes down, then it will trap it, right? But I believe that the mouse will just easily be able to push its way out because there's no lock system over here to stop it from pushing itself out. So it wouldn't be really effective as a trap, but the concept is pretty good. So moving on to my next sketch. So this is my third sketch. I'm going to show my views. So this sketch actually involves two parts to it. So this is my isometric view. So in this part of the trap, there will be two. This is a two-in-one trap. So in this part of the trap, it has a slide-in feature, and in this one, on this side of the trap, it has a slider. So essentially the whole purpose of this is to attach two of the traps together and have them as one, or you could like take it off. So it's basically a two-in-one mouse trap. You wouldn't it would be, the purpose would be that. So this is my isometric view. This is my top view. This is my front view. This is my bottom view. This is my left side view, and then this is my right side view. So I'm going to explain what this sketch is. So in this sketch, there's actually a lock system. So this this beam right here, it's a lock. So whereas the previous sketch, it goes up and down, the hatch control over here goes from sideways. So it'll close sideways. And then due to that, it'll lock into this bottom hatch part over here. There will be a space over here for the once the hatch comes down to fit inside snugly. And this is a lock over here as well for it to not for the rat to not move push itself out from the inside once it's captured. So in this one, I actually have an ultrasonic sensor, and these are my this is my Arduino, and this is my button, and this is my servo motor. So things to note, that there's only one servo motor to capture and release. They're using an ultrasonic sensor instead of a PIR sensor. There's a lock system, and there's more than one compartment, so meaning that there's a sliding attachment. So the mousetrap would have one side that is a sliding part, and the other side over here would be the slider that I drew over here. So essentially, you would be able to connect two traps together to fit into one. So therefore, adding more compartments. So that was the whole purpose of this sketch. The only thing I didn't really like about this sketch is that the way it looked. I just didn't like the aesthetic of it. I also believe that the servo motor would not be able to carry this much load and weight, like moving it left like upwards and downwards, so the sideways. I just don't believe that the servo motor, the small servo motor, will be able to move the whole sheet up and down effectively, and that's just something I'm concerned about. And yeah, that's basically it for my first sketch. I'll just explain my views over here. Currently this is a closed position, so this these hatches over here just indicate that this is my hatch closed, and this is my lock, and this is my bottom lock. So currently my hatch is closed, and over here the hatch is closed as well, and then the hatch is closed, and then the hatch is closed. So this is my third sketch, and now my final sketch is is this. It involves some aspects of my previous sketch, is how it has the two-in-one set on like the sliding parts. So I'm going to show my views. So this is my isometric view. This is my top view. This is my bottom view. This is my no, this is my front view. This is my bottom view. This is my left side view, and then this is my right side view. So essentially what this design was is that I made it shaped like a cheese piece. So this fits with my whole purpose of my mouse trap, is that to trap mice, and then the whole concept kind of like matches perfectly because it's cheese and mice. So this sketch is different because it has my servo motor rather than on the top. It has it attached on the side, and rather than the hatch directly attached to the servo, it has a wire attaching the hatch and the servo. So this would lift the wire, which will therefore lift the hatch. The hatch is on the outside, and then these are my sliding parts. So and my Arduino cover is on the top, and this is my button. So things to note, it only uses one servo motor to capture and release, just as my previous one. It uses an ultrasonic sensor instead of a PIR sensor. There's more than one compartment, so like a sliding attachment. The design is shaped like a cheese piece, the compartment which complements the purpose as the device is relating to mice or rats. So it makes it aesthetically pleasing, whereas just a box, so it gives a little bit more pizzazz to the whole innovation project. So it uses a wire attaching to the servo motor, whereas a servo motor directly attaching to the hatch. So the only thing I was just a little bit concerned about this sketch is that since my design goes up to a point, right? This is not really a point. I was thinking of originally making a point, because like if my design would go up to a point like how a typical cheese piece looks like, I was just concerned about the fact that when the mouse goes inside, it won't have enough space for it to go all the way through, and then it would just be too narrow for it for the mouse at the top. Therefore, it wouldn't go through, and then it wouldn't like trigger the sensors, and it would just back out. So it wouldn't fit inside the whole trap once it's closed. I could fix it by like making the whole trap longer than like the current dimensions, which are like 40 centimeters by 20 centimeters by 15 centimeters. That's the same dimensions I have for all of my sketches. I have 40 centimeters length, 20 centimeters width, and 15 centimeters height throughout all my sketches. So I would just need to make this longer for it to for once it comes to a point, it doesn't the mouse still has enough space to go inside. I like researched and I found out that the average mouse is about 40 centimeters long, 30 centimeters to 40 centimeters long. So, and this is like the adult amount. This is the size of an adult rat. An adult rat could be about 30 centimeters to 40 centimeters long. So currently this is why I never brought this sketch up to a point. I kind of left it a bit flat, but I'm still concerned about how it would be. I also realized that the rather than the sensor directly being straight, since it's on an angle, since it's going to come to a point, the sensor is also going to be on an angle. So rather than sensing stuff right in front of it, it's going to be on an angle. So that's something to consider as well. So basically, what I'm going to do now is I'm going to test out some of these sketches. I'm going to make prototypes of these different designs, and I'm going to see which one is the most effective. I like this design right now. Just because how it's shaped and how it is, and I also think this design, my third sketch, is practical. Oh, I forgot to also mention that the only bad thing about this design is that it doesn't have a lock system like some of my previous sketches, because like when this hatch would close, the mouse would just be able to push itself out. So this sketch also doesn't have a hatch system. The only sketch I have currently that has a hatch system is my third sketch. So I'm gonna have to I like this sketch a lot, but I'm gonna have to experiment and find a way for it to add a hatch, to add a lock system. So I'm gonna make different prototypes of some of my different sketches and compare them and see how effective each one is, and which one I should make for my final, and some aspects I could take from that to make my final. Okay, so this is my first test. It involves a PIR sensor and a servo motor. So I first wrote this code out on Tinkercad, and this is my code, and this is essentially the same setup as what I have over here. The servo motor is going to be used as a hatch for the door to be closed, and the PIR sensor is going to be used to detect the movement of the mouse when it's inside. So I'm going to start this simulation, and over here the servo motor is setting up. So let's pretend this is the mouse. Once it goes inside, as you can see, the hatch closes, so the mouse will be trapped inside. Now once you press this button, this will release the mouse. There's a delay on this button, so you have time to walk away, and now you could see the hatch is open, and now the mouse could be released. So the hatch closes and it opens. Later on, if another mouse comes, it could come and the hatch will detect it yet again, and then you could use the button to open this hatch, and the mouse will be set free. So that is the general idea. So now to test if it works in the real life aspect. So this is my PIR sensor. Currently, it's in its original position, which is the hatch is open. This position is where the hatch is open, and theoretically, if I put any motion in front of the sensor, it should move. So let's test that out. So currently, the way it's working is that it's not detecting my hand. It's not detecting any movement as my servo motor is not moving. Um, in a real life aspect, when a mouse is coming, it should detect it right away, but clearly it is not detecting any motion. It only detects it if there's vigorous contact with the sensor, and you could see that it moved, but it's not very effective. So to reset it, you would need to press this um, button, as I mentioned before, and then it would open up the hatch yet again. But as I explained before, it's not very effective, as you need to have the sensor is not able to detect movement as well as other sensors such as a proximity sensor or an ultrasonic sensor. Okay, so this is my code that I did again, that has my ultrasonic sensor code, since my PIR sensor code wasn't working. So this has involves a trig my trig pin over here, and then my float which is my duration, and my float for my distance. So this is just setting it up, and then um, and this basically is setting up the distance. So like if there's anything detected less than a distance, and these are my if statements for my distance. Previously my code was set up for my PIR sensor, which was this code that had a include servo, and then um, it had a PIR. It had like an input pin, and then it had a PIR, and then it had a miser, and then it had like other code that was specific for the PIR sensor. However, since I explained previously it wasn't working properly, so I had to do an ultrasonic code. Hello everyone, this is my one of my tests for my mousetrap. This involves my so-called mouse, and this is my hatch, which is in the open state, and that is my ultrasonic sensor. So let's begin the test. So as you could see, my hatch is now in the closed state, and the mouse is inside. It's inside, it's behind the ultrasonic sensor. So now the mouse is trapped. So whenever you want to release the mouse, you would press this button. There's a delay of 5 seconds for you to walk away, and then this mouse is able to get out. And now the mouse, since it got out, when there's a delay for this sensor, so in that there's a 5-second delay for you to walk away, and then there's a delay for the sensor to not be active anymore, so the mouse could get out without activating that sensor. So now if you would say that would reset the whole mousetrap. So now let's suppose that another mouse comes. This will happen. So as you can see again, the mouse is inside and the hatch is closed. You would press this button, delay 5 seconds, and then this mouse would get out. Okay, so this is one of my prototypes in action. This involves my servo motor attached to the hatch, and this is my lock that will prevent the hatch from being open from the inside. Um, for my sketch, I have included this ultrasonic sensor on the side, but for just this quick test, I'm you want to just leave it at the top, but it's actually supposed to be on the side. So this is just going to be a quick test of it working. So let's do it. So currently it's in the closed state. So while you will press this button, and then it would open, and then you could see that the trap is now open. If there's something in front of the sensor, then it will close. So if the sensor was on the side, it would have detected something in front of it and closed the hatch. Alright, now I have decided to add my ultrasonic sensor to the side instead at the top, as I believe that doing this will show the most potential of my sketch and how it would actually work in a real life scenario. So currently my trap is in an open state and my so-called mouse is inside. And now let's begin this test. So as you could see, that my mouse went inside and the hatch closed, so meaning that the ultrasonic sensor was triggered. So this is a good news. And now if I'm gonna press this button, and now this has opened the hatch. So now my mouse will be able to get out. I also know this lock that I have currently is way too thick and way too big. So in a real life scenario, the mouse would have to walk over it, and that wouldn't be good. And I also know that this hatch is moving into the space the mouse actually has to go in. So like that's an easy fix. I would just need to adjust the rotation of the servo motor. Currently it's only 90 degrees. So I would just adjust that so it's a bit more so it doesn't come into the way. And the way I would fix this problem is by for the lock being too high, I would make the base thicker, and then I would just have this a little bit higher than the base, so not too much higher like it is currently. Overall, this sketch is pretty good, but it just requires a few tweaks, such as this base being thicker and the rotation being adjusted. Um, but I'm going to also try out another sketch I drew and compare them, which one was more effective and which one was better. Okay, so this is my second prototype. This involves a lever function that's attached to the servo motor, and this is the hatch that is attached to a hinge that I just DIY'd with some tape and glue stick, and I just made a hinge. Um, and the wire is attaching the hatch and the servo motor. So the servo motor is attached to the side, and then there's the ultrasonic sensor on the side as well. Currently, due to my last code that I uploaded for my other prototype, when the so-called mouse, which is just my car, goes in front of the sensor, then it closes. No, then it opens, and then when I press the button, then it closes. It's actually supposed to be the opposite. So when the car is supposed to go in front of the sensor, the door is supposed to close, and when the button is pressed, the door is open. But currently it's doing the opposite. So I'm just gonna demonstrate. My car is inside over there, so I'm just gonna demonstrate real quick. So as you could see, pressing the button closes the hatch, but it's supposed to open it. So what I just did right now is I moved my car in front of the sensor. So I'm gonna show right now that I have my car in my hand right now, which is my mouse. So I'm gonna press the button to make the hatch closed, and now I'm gonna use my car to open the hatch. So the code itself is functioning, and the way I want it to work is functioning. All I have to do is make the code opposite. So when it comes in front of the sensor, the hatch actually opens. And the way I would do this is by just changing the degrees, so switching them around. I would also cut this extra piece of wire so I could increase the degree a bit, so the hatch goes further up. Overall, I like this design better than the last prototype because it is more aesthetically pleasing. The only bad thing about this prototype is that it doesn't have a lock system like the previous prototype. The hatch is located on the outside, meaning that once the rodent is captured, it will just be able to push its way out of the hatch. I would need to figure out a way so there could be a lock system for this design. Okay, so this is my next prototype after my last one. In this one, I have my door on the inside, whereas on the last one, I had the door on the outside. So this would provide a lock for my mousetrap, as in the last one, there wasn't any lock. This one obviously has a lock because this door is bigger, so it can't, the mouse can't push through. So let's begin the test. So I'm going to press this button, and you can see it opens, and then my mouse could get out. Once you want to set it up again, that's how it happens. And then if my mouse goes in front of the sensor, it closes. So when I want to release it, I press the button, the sensor opens, then my car could come out. Now if I were to open the top of the hatch up just to show you that the lock is effective, so I'm just going to open this hatch up on the top and show you. Okay, so currently this is my door. So if I push on it from the back, it doesn't come through. The mouse wouldn't be able to come through. So you could see that if I push on the back, the mouse wouldn't be able to come through due to the extended edges right over there. So this provides a lock system. Okay, so this is another one of my prototypes. This is basically the same one as my last prototype. However, it's instead it's shaped like a cheese piece. So it's pointed at the end, and it's this is my mouse. And now let's begin the test. So I just left this slit open over here so you could see the mouse actually go inside this time. So it's easier to view. But in the real final product, it would be closed. So let's just begin. So as you could see, the hatch had closed because my car had gone in front of the sensor. So now my mouse is inside. So now if I press this button up here, the hatch is going to open, and now my mouse could get outside. The only bad thing about this design is that it has to be the length of the design has to be extended, so more than 40 centimeters for it to come to a point, or else if I just use the 40 centimeters that it already has, then it will be too small for a average rat to fit inside. So I would need to extend the ends for it to come to a point, and this just makes the whole mouse trap look a bit too big and bulky. So I'm going to have to consider that factor. Even though my prototype 3 was good, I wanted to make this prototype to check how the trap would be if it was cheese piece shaped. As I originally thought the cheese piece shaped idea was perfect, I no longer think that because the idea is not practical. If I wanted the cheese piece aesthetic, I could just add it to the prototype 3 design. So this is my final product of my mousetrap. As you could see, that my hatch is currently open, and inside there's sheet metal lined. On the outside, I painted it yellow, and I've created a cover for my Arduino and breadboard to sit inside. And my wires are also lined with tape so they are not disorganized. Currently, my power is coming from the computer, but I could also connect it to a battery. So um, let's begin our test. So this is my mouse. I'm gonna move my mouse inside. So as you could see, my mouse had detected the sensor, therefore resulting the hatch to close. And now the mouse is trapped inside. Once you want to release the mouse, you would come up here and you would open this hatch, revealing the Arduino and the buttons. You would press this button, and then this hatch would open. Now the mouse would be able to come out. Even though my product functioned exactly how I wanted, I could still improve. I could have managed my time more as I had to spend less time on aesthetics near the end of the project. I didn't finish making my cheese aesthetic, and I was just able to accomplish a yellow base coat. What I could have done next time to improve my product is to use a bigger servo motor instead, as all I had available was a micro servo motor. By doing this, I would be able to lift the hatch easier and would also be able to make the hatch its proper material. Currently, the hatch is just made of cardboard, so the micro servo motor can lift it. However, with a bigger servo motor, I can make my pest arrest trap more realistic and practical. Another next step to improving the product can be making it lighter. Although I was inclined to use sheet metal since rats and mice can bite through it, the sheet metal resulted in my product to be quite heavy. On top of that, I added plywood around the sheet metal to make it more structurally sound, all in the motive to not allow the rodent inside to escape and bite through. If I had the chance to improve, I would also make compartments within my Arduino cover for each of my components, such as the Arduino Uno, the battery, and the breadboard. Although the breadboard I had was already able to stick to the surface, my Arduino Uno and battery had no sticky bottom. Therefore, I would make some compartments or parameters for my Arduino and battery to fit into. Lastly, an important part to mention is also the slide in feature. I was able to 3D print that feature, however, the dimensions came out too big and it required a lot of filing and sanding to correct. Due to the amount of time left, I was not able to print the correct sizes again and was forced to file and sand it. I did accomplish that to the best of my abilities, however, I didn't add it to my final product because I felt like it didn't look nice. To correct this small problem, I will just correct the small errors in the dimensions and print again.